Have you ever wondered what it would take to connect the human brain to a computer? For decades, this has been the stuff of science fiction. But what if I told you it's becoming a reality, and not just for a select few, but potentially for millions? Today, we're diving deep into one of the most ambitious technological ventures of our time, Neuralink. And specifically, we'll be uncovering the secret sauce that could make it all possible, their groundbreaking automation strategy for mass production. This isn't just about a single incredible piece of technology. It's about how to scale that technology, how to make it safe, accessible, and affordable. The challenge is immense. Brain-computer interfaces, or BCIs, involve incredibly delicate and precise procedures. We're talking about implanting thousands of microscopic electrodes into the brain. Doing this by hand, one patient at a time, would be painstakingly slow, incredibly expensive, and prone to human error. It would never achieve the scale needed to help the vast number of people who could benefit, from those with paralysis to those with neurological disorders. This is where Elon Musk and the team at Neuralink are thinking differently. Their vision isn't just to create a BCI, it's to create an entire system to manufacture and implant it on a massive scale. The key? Automation. Imagine a factory, not for cars or smartphones, but for neural implants. And imagine a surgical robot, not just assisting a human surgeon, but performing the entire implantation procedure with superhuman precision. That's the future Neuralink is building, and it's a game changer. Let's break down the first piece of this puzzle: manufacturing the implant itself. The Neuralink device, often called the Link, is a small coin-sized capsule. But inside, it's a marvel of microfabrication. It houses custom-designed chips, a battery, and wireless communication systems. Attached to it are the threads, ultra-thin, flexible polymer strands, each thinner than a human hair, packed with electrodes. There are thousands of these electrodes. Manufacturing these threads and assembling them into the final device requires a level of precision that is simply beyond consistent human capability. This is where automation comes in. Neuralink is developing a fully automated assembly line. Think of robotic arms with microscopic grippers, guided by advanced computer vision, picking up these delicate threads and weaving them into the device. Every step, from fabricating the threads to sealing the implant's biocompatible casing, is being designed for automation. This not only speeds up production exponentially, but also ensures an incredible level of quality control. Each implant can be identical, tested, and sterilized without ever being touched by a human hand, minimizing contamination and defects. This is how you go from making one device in a lab to producing thousands and, eventually, millions per year. But manufacturing the implant is only half the battle. The other, even more mind-boggling part is the implantation process. This is where Neuralink's R1 robot comes into play. The R1 is a surgical robot designed specifically for one task: to implant the Neuralink threads into the brain with unparalleled precision. Why a robot? The human brain is an incredibly complex and delicate organ. The cortex, where the threads are implanted, is filled with blood vessels. Puncturing even a small one could cause significant damage. A human surgeon, no matter how skilled, has natural limitations: a slight tremor, a moment of fatigue. The R1 robot has none of these. It uses a sophisticated array of cameras and optical coherence tomography to create a real-time, high-resolution map of the brain's surface. It can identify and navigate around every tiny blood vessel, plotting a unique and safe insertion path for each of the 64 threads it implants. The robot's sewing machine-like needle, which is also incredibly fine, then inserts each thread one by one. The entire process is designed to be so minimally invasive that it could one day be as routine as LASIK eye surgery. The goal is a procedure that takes under an hour, potentially without general anesthesia. This level of speed and safety is simply unattainable without full automation. The robot doesn't just assist, it performs the entire microsurgery. So what does this two-pronged automation strategy in both manufacturing and surgery truly mean for the future? It means scale. By automating production, Neuralink can drive down the cost of the implant itself. Just like Henry Ford's assembly line made cars affordable for the masses, Neuralink's automated factory could make BCIs accessible. By automating the surgery, they can make the procedure faster, safer, and available in more places. You wouldn't need a handful of world-renowned neurosurgeons, you'd need trained technicians to oversee the robot. This distributed model is the only way to meet the potential demand. Think about the implications. For people with paralysis, this could mean regaining control of limbs or communicating through thought alone. For those with blindness or deafness, it could mean restoring sensory input. And looking further into the future, Neuralink envisions a world where this technology could help with memory loss, anxiety, and a host of other neurological conditions. The company's mission is to create a generalized brain interface to help solve these pressing medical issues. None of this is possible if the technology is confined to a laboratory or available only to a few wealthy individuals. Mass production and automated implantation are the bridge from a powerful concept to a world-changing reality. Of course, the road ahead is still long. Neuralink is still in the early stages of human trials. The technology needs to be proven safe and effective over many years. There are immense ethical and regulatory hurdles to overcome. But what's clear is that they are not just solving a scientific problem. They are solving an engineering and logistics problem. They understood from day one that to truly revolutionize brain technology, you have to revolutionize how it's made and delivered. Their focus on automation is not just an efficiency hack, it is the fundamental pillar upon which their entire vision rests. It is what separates Neuralink from a research project and turns it into a potential global infrastructure for neural integration. The future of brain-computer interfaces is being built right now, not just in neuroscience labs, but on automated assembly lines and in the programming of surgical robots. It's a bold, ambitious plan that sounds like it's straight out of a movie, but the progress is real. By tackling the challenge of scale head-on, Neuralink is paving the way for a future we've only just begun to imagine. It's a testament to the idea that the biggest breakthroughs often require not just a brilliant invention, but a brilliant plan to bring that invention to the world. What are your thoughts on this automated future for brain technology? Does it excite you or does it make you cautious? Let me know in the comments below. I'd love to hear what you think. And if you enjoyed this deep dive into the tech of tomorrow, make sure to hit that subscribe button and turn on notifications so you do not miss our next video. Thanks for watching, and I'll see you in the next one.